using a booster system. The unit will not generate domestic hot water above 95 degree F in heat pump mode, so that will, above 195 degrees, be using the electric elements in those extremely rare conditions that might exist. Active cooling, you can adjust it anywhere from 41 degrees up, and it operates up to very, very effectively up to 110 degrees, 115 degrees ambient outside. So the design parameters, again, 120 degree supply water temperature, ideal for radiant heating, air handlers, convectors, radiators, low temperature baseboard, chill water. It can be used in any wide range of chill water applications, but of course we're talking about mostly space conditioning in this case, but not necessarily. And of course, keep our eye on sufficient storage in your domestic hot water sizing to assure that people have all the hot water they want. So our design considerations in California, the good news is we're in a Mediterranean climate zone, so that we're able to have annualized COP performance in the minimum 3.2, but if we go down to Southern California, consistently over 4. These are the type of COPs that you'll see in geothermal heat pumps. You'll see some stretch to higher than that, though it's some questionable under what conditions. So the nice thing about California is our Mediterranean climate zone, the ability to get such high efficiency out of these low ambient heat pumps. They're a target market to keep in mind are the municipal utilities and other utilities that have 14 cents a kilowatt, such as Los Angeles has 13-cent kilowatt flat rate. Means right off the bat it's substantially less expensive to be operating an altherma heat pump than it is for a natural gas unit. Here's a little case study of a place in Belgium, a little home that actually Daikin owns, and the net of this is that they have an annualized 3 COP in this home. Now, just note that this home is in Belgium, which is the same latitude as Calgary. We are a much more easy climate in terms of ambient air temperature, so you can see that if they can get those sort of performances and that kind of latitude, in fact, they're very much understating their performance, is what we believe. What we've seen so far in working with Daikin is they're extremely conservative in providing data on their products. And test homes we have in Portland, we've seen it regularly exceeding the performance criteria as laid out in the book. And you'll find that consistently as you go through training, which is a nice place to be. Now, they have a sizing and selection software. And on January 15th, you'll see, we'll promote a little later, a webinar we'll be doing on this selection software and on sizing and other design issues in more depth. But in essence, you're able to give the location of this system and the parameters of your design, and to be able to come up with a product selection that will also tell you what the seasonal COP is on the product. Actually, this is one that's in, I think, near Helsinki, and they have a seasonal COP of 3.9. So again, we'll do more on this in terms of selection. In the meantime, we're happy to have engage in conversations and doing running selection software for whoever needs it. Simply need to give us a call, and we'll run this software in the meantime. One of the little side bars of this selection sizing software is that one of the outputs, and it provides many outputs in terms of economics as well as sizing, is it provides all the field settings report. So the technician in the field merely needs to go into the control and set the default values according to the output of the unit without having to calculate on site where the various settings should be placed on the unit to match the application. So, some markets for altherma. Right off the bat, very cost effective, less than half the cost than geothermal. And I think you'll find that there'll be many applications that were no longer available, that were not available in the past for heat pumps, and geothermal will now be available. Now at 54,000 BTUs, you're going to see these are viable depending on your heat loss, which is going to be shrinking under the new Title 24 requirements. That we can do homes, that are 1,000 or less, 800 square feet to 3,000 square feet very commonly. So there may be homes that use 2 of these or more on very large homes, but will be far less than geothermal. Again, any place there's propane gas, these are a very viable option for people. We'll get into net zero energy homes, but this is a linchpin for making net zero energy homes work in California. There are several factors that have changed, but having cost-effective, cash-positive net zero energy homes is no longer the talk of dreams. It's here and now. Multifamily housing is used in very commonly in Europe already. In New England, there are several multifamily projects. We're exploring in California the viability, but certainly if you look at it from a development standpoint, not having to bring natural gas to a project, no metering costs, no gas piping costs, no combustion venting costs, which we all know in multifamily can be a very arduous process getting that taken care of, can be offset with the fact that this is also a very green product and very viable for those projects which want those credentials. Of course, we can do everything: heating, cooling, and domestic hot water, and everything but the domestic hot water can be outside. Space considerations. This could be a very good choice. Multifamily, we're typically using an air handler or convectors, but certainly we can use radiant floor heating as well. These are very quiet and space saving. So we'll be examining that. They cost more, certainly first cost, than you'll see out of some options that are available. When the developers start looking at all their actual development costs, it would appear that these are going to be a very attractive option for that market segment. So also, while our focus is on residential with the altherma, there are all sorts of different applications where one, in essence, would want a water-based mini-split that does domestic hot water. All sorts of little applications where domestic hot water is desired, as well as heating and cooling. Or they can think about it as a water-based VRV, doing heating or cooling with domestic hot water. Instead of doing it with refrigeration, we'll do it with water. It's frankly far less complicated to install and commission than a VRV. So VRVs are a very attractive technology. It gives you another option in the commercial front. And the other way to think of the altherma is just a reverse cycle chiller. So you can be using chilled water without a cooling tower, plus heating and domestic hot water for any number of commercial applications, breweries, wineries, etc., where you're looking for taking care of small loads and fractured ones. So looking at where does this stand in terms of the options that people might have out there for, let's say, using a condensing boiler system, and I'm not including domestic hot water for the purposes of this comparison, but you take a condensing boiler and the mechanical room associated with that, and that's parts and labor, a cooling condenser. We are at very least, you're going to have components that cost a contractor $7,000.